Okay, so previously we talked about the general idea of differentiation, slope, and rate of change in section 1 of chapter 3. I'm now starting with section 2 of chapter 3. That's about differentiation rules. Differentiation rules. Of course, we had in chapter 1, in section 1, a general idea about differentiation, but we have got some differentiation rules to find the derivatives of the functions that will be given to us. We will start, of course, with the simple rules that we have got for differentiation. The very first simple rule that we have got is the derivative of a constant function. So if we have got a constant function, how does the function look like? F of x is equal to c, where c is any real number. Any number that we have got. C is maybe equal to 3, is equal to 0, is equal to minus 3, is equal to root of 2. Doesn't make a difference. That c is any number that is given to us. So in general, if you have got f of x that's equal to a constant function, what is the derivative of that function? Of course, that's equal to 0 at any point of that function on the real number line. So let's give some examples about that. If you have got f of x that's equal to 3, since 3 is a constant function, what is the derivative of that 3? That's equal to 0. If you have got f of x that's equal to root of 3, since root of 3 is a number, is a constant number, constant function, so f prime of x is equal to 0. If you've got f of x that's equal to 0, 0 is again a number, it's a constant, so it is a constant function. Since it is a constant function, the derivative is also equal to 0. If you have got f of x that's equal to minus, for example, 1 over 2, 1 over 2 is again a constant, minus 1 over 2 is again a constant function, so f prime of x is equal to 0. So what do we have for the first rule, for the first differentiation rule? If you have got a constant function where f of x is equal to c, c is given any number, the derivative of that constant function is equal to 0. And here are the examples. The second rule that we have got for differentiation is called the power rule for positive integers. What is a power rule? Or not just for the positive integers, the power rule in general. If you have got f of x that's equal to x to the power of n, where n is where n is a real number, how do we find f prime of x, or the derivative of that function that we have got? That power will come down and will be decreased by 1. So that power will come down in front of the x and will be decreased by 1. So how do you write it in general? That will be n multiplied to x, and that n will be n minus 1. Okay, that is decreased by 1, minus 1. So let's give some examples again on the power rule. If you have got f of x that's equal to, for example, x squared, that's a power function. Why? Because we have got x with the power of 2. So f prime of x is equal to what? Is equal to 2x to the power of 2 minus 1. We are decreasing the power by 1, so that one will equal to 2x to the power of 1, and of course we're not writing the power 1. If you have got f of x that's equal to, for example, x to the power of 4, how do we find the derivative of that function? That will be 4x to the power of 3, decreasing as we said, we are putting that 4 in front of the x, and we are decreasing that 4 by 1, so that will be 4x to the power of 3. If you've got, let's give other examples. If you've got f of x that's equal to root of x, first we are changing that root of x into a power, so that one is equal to x to the power of 1 over 2. As you know, we can write a root as a power of 1 over 2. How do we find the derivative of that function? We are saying, of course, that 1 over 2 comes in front, that will be 1 over 2, x to the power of 1 over 2 minus 1. We are decreasing the power by 1 again. Okay, so how will that be? That will be 1 over 2, x to the power of 1 over 2 minus 1 is equal to what? Is equal to minus 1 over 2. So that one will be minus 1 over 2. If you want to rearrange that function, that derivative of the function, what shall we do? That will equal to 1 over 2. Since we have got a negative power, so that one will be upside down. So this one equals to x to the power of 1 over 2. And if you want to change that power into its original, that will be 1 over 2 multiplied to 1 over root of x. So, so far we have studied what? The derivative of a constant function is equal to 0. And if you have got a power, the power will come down next to the x and the power will be decreased by 1. I will give another example about this one. If you have got f of x, okay, with a negative power. For example, if you have got f of x that's equal to 1 over x to the power of 6, how do we deal with this one? Again, we have to change that function into a power function. And of course, that one is equal to what? If we take it to the numerator, it is equal to x to the power of minus 6. What is the derivative of this one? Again, the minus 6 comes in front. Okay. And this one will be decreased by 1. So minus 6 minus 1. We are decreasing it by 1. So that one will equal to minus 6 x to the power of minus 7. If you want to rearrange this one, that will be minus 6 over x to the power of 7. And that's it for a power function. Next, we have got some examples in the lecture notes. In the lecture notes of section 2, we have got example number 1. We have got a that's equal to x to the power of 3. It's required from us to find the derivative of this one. That's equal to, of course, f of x. How do you find the derivative of this one? Of course, the derivative of this one is equal to 3. The 3 comes down. X to the power of the 3 is decreased by 1, so that is equal to 2. The second one, we have got b is equal, f of x is equal to x to the power of 2 over 3. X to the power of 2 over 3, if you want to find the derivative of this one, how do you find it? F prime of x, that's equal to 2 over 3, x to the power of 2 over 3 decreased by 1. Okay, so that one is equal to what? That one is equal to 2 over 3 x to the power of, we have to equalize the denominators of this one. That one will equal to 2 over 3 minus 3 over 3. 2 minus 3 is equal to minus 1 over 3. If you want to rearrange this one, that will equal to 2 over 3, since this one has got a negative power, so it comes to the denominator. And if you want to change this one back to a root, that will equal to x under the cubic root. We have got the third example, D, part D. F of x is equal to 1 over x to the power of 4. Again, we have to change this one to a power function. So how do we change it to a power function? It is in the denominator. We're taking it up to the numerator, so that will equal to x to the power of minus 4. How do we find the derivative of that function? If prime of x is equal to minus 4 comes in front of the x, and that power will be decreased by 1. So decreasing by 1, it will equal to minus 4 minus 1. Let me write it for you. Minus 4 minus 1. So that one is equal to what? Minus 4 x to the power of minus 5. If you want to rearrange this one again, we have got this one is equal to minus 4 1 over x to the power of 5. Why did it come down to the denominator? Because we've got a negative power in here. The Last example, we have got f x to the power of 2 plus pi. Leave this one because we've got pi here. You will need a calculator. Since a calculator is needed, do not do that example. We've got e. The example is given x to the power of minus 4 over 3. That's the function that we have got. Of course, if you can write f of x is equal to this one, we can also write y is equal to this one because f of x is equal to y. So if you want to find the derivative of this one, how can we find it? Again, y prime is equal to minus 4 over 3. The power comes down in front of the x, and x to the power of minus 4 over 3 minus 1. We are decreasing the power by 1. So that one is equal to what? Y prime is equal to minus 4 over 3. X to the power of, how do we calculate that one? Of course, without using calculators. We've got 1. Here we have to equalize the denominator of this one with that one. So that one will equal to 3 over 3. So minus 4 minus 3, that's equal to what? Minus 7 over 3. Rearrange this one, y prime is equal to minus 4 over 3. And in the denominator, x to the power of 7 over 3. Okay. So that is all about the power rule. Next, we have got a constant multiple rule. What is a constant multiple rule? If we have got a function and that is multiplied with a constant number. If you have got, for example, f of x, and we have got g of x. F of x is equal to c multiplied to g of x, where that c is any constant, any number multiplied to that one. If you want to take the derivative of that function, how do we find the derivative of this one? We can say that the derivative of this one, f prime of x, is equal to c, without changing the c, without taking the derivative of c, multiplied with the derivative of the function g. So that will equal to what? C multiplied to the derivative of that function. We do not say that the derivative of that constant is equal to 0 because the constant is not alone. It has got a function with it. So we cannot say that it is equal to 0. We are saying that the derivative of that function is equal to that c multiplied to g of x. Let's give some examples about this one. If you've got f of x, that's equal to 3x to the power of 4. How do we find the derivative of this one? That 3 is the constant in here, and that x to the power of 4, we can consider it as the g of x that's given in here. So how do we find the derivative of that one? We can say that f prime of x is equal to that 3, okay, the constant that we have got here, we're just putting it down as it is, multiplied to the derivative of that function x to the power of 4. So f prime of x is equal to what? 3. What is the derivative of x to the power of 4? That's 4x to the power of 3. Multiply this one with that one. That's equal to what? F prime of x. That's equal to 12x to the power of 3. And of course, when you are doing lots of examples, you can simply do the calculation or taking the derivative of that function easily. Okay, look, the same function we have got, but since you know how to do it directly, you do not need to do those steps. You're straightforward saying that 4 is coming next to the 3, so that will be 4 multiplied to 3, that's equal to 12. And of course, the derivative of this one is x to the power of 3. You do not need to do those steps when you're doing lots of examples. Okay. That's about constant functions, power rule, and constant multiple of a function. Okay, that was constant multiple rule for differentiation.